time to make some music or noise. So what I have here is a 555 timer with a LDR Light Dependent Resistor, a few more components, and essentially it's an astable vibrator. So let's turn off that fantastic music for a moment. And what I'll do is show you the circuit. But first, what we need to do is figure out for this LDR, what is its rough resistance range. So if the meter hooked up to it, it's roughly 3.6 kilo ohms. Now, it can get a bit lower. I've got it down to almost 2,000 ohms. But that gives you the base level for building the rest of the circuit. And here's the circuit. So just a simple astable vibrator. 1,000 ohms here. This one is the LDR, so it gets to vary. The capacitor, I'll get into that in a moment. I've got it all in a spreadsheet. Here's the formulas for figuring out the time that it's high, time that it's low, the total time for each cycle, and the frequency it generates. So what I'm doing is, this is the output. It'll be a square wave. I've got a resistor for limiting the current to the base of the transistor, which is a BC337. You can use pretty well any NPN transistor. I picked this for 800 milliamps. I'm using an 8 ohm speaker. This part here is just 0.01 specs from everywhere else. And 0.1 here. So, let me get to the spreadsheet. So here's the spreadsheet. I used 1,000 ohms for R1 for all of these calculations. You can change that, though I've read that apparently 1,000's about the lower limit you want to use there. For LDR, which is R2, I set the first value at 2,000 and I went up very rapidly in the resistance. For C1, I used 3 different values. Right now the table is showing for 0.02 microfarads, and the next 4 columns are the output for that. But I also tried 0.03 microfarads and 0.047 microfarads. And those are the 3 columns to the far right. So you can see that you can actually set what the highest frequency you want by selecting essentially the capacitor. So if you want one that has lots of high frequency in it, but you can still get way down there by using the cone of silence, or low frequency in this case, you can set it up at 0.022 and you've got a huge range in there for frequency. But if you want something that's a much more lower frequency, which actually kind of, I think, sounds a bit better, then 0.047 microfarad is pretty good. But there's a trade-off. If you're using the 0.047, then this thing's constantly on and you can hear it. Whereas at the 0.022 microfarad, or even maybe a bit lower capacitance, you could actually get it set so that in normal light you can't hear it because the frequency is too high, and only when you move in towards this LDR you'll see it. So it's a trade-off here and there. So comparing it with the previous video that I did on oscillator, this is the Avalanche Oscillator, where you snip one pin off of the transistor, the base pin. This is running right now at 15 volts. Does require a bit more light. And you can see there's obviously a big difference in number of components. The Avalanche required 1, 2, 3, and speaker, and of course power supply. And this one over here required, let's see, 1, 2, 3, 4, 5, 6, 7, 8 parts. Ignore this. So, much simpler. I think this actually is producing a bit nicer sound, but they're just different. So if you want to make your own music, noisemakers, this is a nice simple project and really doesn't take that long to make. I actually assembled this correctly the first time. Something new for me. So that's it. There's the next part is actually about the 555s. I've actually got quite a collection of them from over several decades. So stay tuned for that if you want to see it. It'll be on in a moment. Bonus time. Let's just compare a few of these 555s. This one here is from around year 2000 or before that. I'm pretty sure they weren't selling counterfeit stuff. Yeah, I even have a few of those packages left. Whoops. And the one on the right is a cheap Chinese one I bought from AliExpress in 2022. I think that logo is supposed to imitate Texas Instrument. It's not even close. Now, these are slightly different. This is an NE555. It doesn't have anything to do with the logo. And these ones, the other ones are TLC 555 CPs. The difference is this has a much wider voltage range going low. The NE555s require a minimum, I believe it's 4.5 volts, and the TLC 555s are good down to around 2 volts. Now the NE555s also, though, have a higher output current or draw of, I believe, 200 milliamps, whereas the maximum on this one is 150 and something else. I'll put it in the corner there. Just some old stock I have. Oh, and there's also this other one. Oops. Texas Instrument logo is a bit different, though no idea if that one's real. And then where's the other one? Ah. There's this one here. And these ones here from Korea. Microamp. Tried looking these up. Wasn't able to find them on the internet, but it didn't look too hard. So I've got a whole bunch of different ones. The AliExpress was got 50 of them for, I think it was $2.20. Probably got what I paid for.